Hello everyone, welcome to Maths with Mr. JN. Today I'm going to show you how to solve this nested root equation, which is root t, root t, root t, root t equals to 27. We have two ways to approach this type of question. First, we solve it externally. When we solve it externally, meaning we have to solve from the biggest root down to the smaller root. Then the other method is solving it internally, solving from the smallest root then to the bigger root. At the end, we will arrive at the same answer. Stay tuned, let's dive in. Solution. If we approach this from the biggest root, we have root of t, root t, root t, and root t equals to 27. Then we square both sides. When we square both sides, we have root of t, root t, root t, root t all squared equals to 27 squared. We move further. Square, we cancel the big square roots. Then left with t, root of t, root of t, and root of t equals to 27 squared. At this point, we have to square both sides again. When we square both sides, we have t, root t, root t, root t all squared equals to 27 squared all squared. If we move further, this will give us, when we square t, we have t squared. This square, we cancel the square root here, left with t, root of t, and root of t equals to 27. We can multiply the power here. 2 times 2 gives us 4. At this point, we apply the law of indices that state that a raised to the power of m times a raised to the power of n is equals to a raised to the power of m plus n. Then we can apply this here. And when we apply that, we are going to have t raised to the power of 3, because we add the power, we have power 1 here. Root of t equal to 27 raised to the power of 4. We move further, we square both sides again. When we square both sides, we have t raised to the power of 3, root of t all squared equals to 27 raised to the power of 4 all squared. When we square t raised to the power of 3, we have t raised to the power of 6. All you do, you multiply the power. Then the square, we cancel the square root, times t root t equal to 27 raised to the power of 8. At this point, we apply the law of indices, which we have here. Then when we apply that to the left hand side, we have to add the power. There is invisible 1 here, which we turn to t raised to the power of 7 root t equal to 27 raised to the power of 8. At this point, we have to square both sides again. When we square both sides, we have t raised to the power of 7 root of t all squared equal to 27 raised to the power of 8 all squared. When we continue, t raised to the power of 7 squared gives us t raised to the power of 14. We just times the power. Square of square roots means square cancel square roots, times t equal to 27 raised to the power of 16. When we apply the multiplication law of indices, which we have here, the left hand side we change to t raised to the power of 15, when we add the powers, equal to 27 raised to the power of 16. To get the value of t, we have to multiply the both powers of both sides by 1 over 15, which is the reciprocal of the power of t. So when we do that, we have t raised to the power of 15, or raised to the power of 1 over 15, so that we have the power of t to be 1, equals to 27 raised to the power of 16, or raised to the power of 1 over 15. When we continue, we have t, 15 cancel 15, left with t raised to the power of 1, which is the same thing as t, equals to 27 raised to the power of 16 all over 15. Then simplify this further. T is equals to 27 can be expressed in base 3, which is 3 raised to the power of 3, or raised to the power of 16 over 15. 3 here, 1, 3 can cancel 15, left with 5. So t will be equals to 3 raised to the power of 16 all over 5 as the final answer. This is approaching this problem externally. Now we want to approach this problem internally, meaning solving from the inside to the outside. Let's dive in. So if we solve from the smallest root to the biggest root, we are going to have root of t, root t, root t, root t equals to 27. We apply the law of indices. We state that whenever we have root of a is the same thing as a raised to the power of 1 over 2. We apply this law here. And when we do that, we are going to have root of t, root t, root t times t raised to the power of 1 over 2. That is this, equal to 27. Then if we move further, in left hand side, at this point, we have product rule of indices or multiplication rule of indices. We state that whenever we have something in this form, which is like a raised to the power of m times a raised to the power of n is equals to a raised to the power of m plus n. If that holds, we are going to apply it here. Then we have root of t, root t. Then if we apply that here, we have power 1 here, meaning 1 plus half will give us t raised to the power of 3 over 2. 3 over 2. When you add 1 plus half, we have 3 over 2. If we want us to do it, we have 1 over 1 plus 1 over 2. All we do, we find the LCM. The LCM is 2. 1 into 2 gives us 2. 2 times the numerator is 2 plus 2 into 2 gives us 1. 1 times the numerator gives us 1. If we add the numerator, we are going to have 3 all over 2, which we have here, equal to 27. The next step, we are going to apply the same law of indices. I will name this to be I, so that we will not be rewriting it, and name this law of indices to be II. Whenever I say we apply I, we know we are applying the first one, and whenever I say apply II, we know we are applying the product law of indices. In this case, we are going to apply I, which is transforming square root to power. If we apply that here, this root will go off. So we are going to have root of t equal to, removing these square roots, we are going to have t raised to the power of 3 over 2, or raised to the power of 1 over 2, equals to 27. Applying I above. Then we apply this I above. Then we continue. We have root of t into root of t times, we multiply the power. In law of indices, we have a raised to the power of m raised to the power of n is equals to a m n, which we apply here. If we multiply the power here, then we are going to have t raised to the power of 3 times 1 gives us 3 over 2 times 2 gives us 4, equals to 27. We move further. We are having root of t into root of t. Now we apply the multiplication law of indices. We add the powers. When we add the powers, we are having 1 plus 3 over 4, which is the same thing as t raised to the power of 7 all over 4, equals to 27. The next step, we have root of t. Now we want to remove this square root. Then we apply the first law when we transform the square root to power. If we do that, we are having t raised to the power of 7 over 4, all raised to the power of 1 over 2, equal to 27. Applying I above. Then at this point, we multiply the powers. If we multiply the powers, we are going to have root of t times t raised to the power of 7 times 1 gives us 7 all over 4 times 2 gives us 8, equal to 27. We move further. We apply multiplication rule of indices, which is a raised to the power of m times a raised to the power of n equals to a raised to the power of m plus n. When we apply that here, this is power 1. Then we are going to have root of t. When we add up the power, we are going to have 15 all over 8, equal to 27. How do we get 15 over 8? Is 1 over 1 plus 7 over 8. The LCM is 8. 1 into 8 gives us 8 times 1 gives us 8 plus 8 into 8, 1 times 7 gives us 7. And when we add up the numerator, we have 15 over 8. Then we continue. Then we want to remove the square roots. Removing square root, we apply. Whenever we have square root of a, we can express it to be a raised to the power of half. At this point, we have t raised to the power of 15 over 8, or raised to the power of 1 over 2, equal to 27. When we multiply the powers, we have t. 15 times 1 gives us 15. 8 times 2 gives us 16, all over 27. To remove this power from t, we have to multiply both sides of the power by the reciprocal of the power, which is 16 all over 15. And when we do that, we have t raised to the power of 15 all over 16, all raised to the power of 16 all over 15, equal to 27 raised to the power of 16 all over 15. 15 we cancel 15, 16 we cancel 16, left with t equals to 27 raised to the power of 16 all over 15. Then we can express 27 in base 3. We have 27 in base 3 is the same thing as 3 raised to the power of 3, means 3 times 3, 3 times to give you 27, all raised to the power of 16 all over 15. 3 can cancel 15, left with 5. Then we have the final answer to be 3 raised to the power of 16 all over 5. Now this is the value of t. As we solve internally, we have the same answer with when we solve externally, which is the same as this. Then what we do, we have to check if our answer is correct. How do we check if our answer is correct? We put the value of t equal to 3 raised to the power of 16 over 5 into this original equation and see if we get 27. as the answer. Let's dive in. Now let's check if our answer is correct. We have root of t, root t, root t, root t equals to 27. We have solved internally and we have solved externally. We can use any of the process to check if our answer is correct. But right now, I'm going to check using internally, the last method which we use. So we have to put t equals to 3 raised to the power of 16 all over 5. Let's see if the left hand side will give us the right hand side. So what we have root of 3 raised to the power of 16 over 5, root of 3 raised to the power of 16 over 5, root of 3 raised to the power of 16 over 5, and final root of 3 raised to the power of 16 all over 5. Will it give us 27? Let's check. Just stay tuned. I know it will take time, but we have to have patience. Patience is the key to success. Now we move further. If we start internally, we apply the law of indices that still a raised to the power of 1 over 2 is the same thing as square root of a. I turn it the other way around, meaning square root of a, that is square root of this, is the same thing as when we raise it to the power of half. So if we apply that, we have 3 raised to the power of 16 over 5, all raised to the power of 1 over 2, times, we write this, which is 3 raised to the power of 16 over 5, all in roots, 3 raised to the power of 16 over 5, all in bigger roots, and 3 raised to the power of 16 over 5 in the biggest root equals to 27. In law of indices, we know that power counters power, where we have a raised to the power of m in bracket, which will give us a raised to the power of mn. So if we apply that here, we are going to have biggest root of 3 raised to the power of 16 over 5, root of 3 raised to the power of 16 over 5, root of 3 raised to the power of 16 over 5, times, when we multiply the power, 2 can cancel, 16 gives us 8. Now we have 8 times 1 gives us 3 raised to the power of 8 all over 5. Will it give us 27? Let's see. We move further. In this case, we have to apply product rule of indices or multiplication rule of indices. We state that when we have a raised to power m times a raised to power n equals to a raised to power m plus n. In this case, we just add up the powers, and the powers are fraction, meaning when we have 16 over 5 plus 8 over 5, this type of fraction is identity fraction, where the denominators are equal. If the denominators are equal, you add up the numerators, which is 16 plus 8 gives us 24 all over 5 as the answer. In here, we write this to be 3 raised to the power of 24 over 5 in square roots, then 3 raised to the power of 16 over 5, then the last one, which is 3 raised to the power of 16 over 5, all in square root equals to 27. If we move further, we have to change this one to power, and the only way to change it to power is to raise it to the power of 1 over 2, where we have square root of a equals to a raised to the power of 1 over 2. And if we do that, we are going to have root of 3 raised to the power of 16 over root of 3 raised to the power of 16 over 5 times, we are changing this to power, which is of this form, which is the same thing as 3 raised to the power of 24 all over 5, all raised to the power of 1 over 2. Will it give us 27? Let's see. If we multiply the powers here, 2 can cancel 24, which is 12. So this will give us root of 3 raised to the power of 16 times 3 raised to the power of 12 all over 5. 3 raised to the power of 16 all over 5, all in root, equals to 27. We have a m times a raised to the power of n is equals to a m plus n, which is product law of indices. When we apply this here, we are going to have, this is over 5, sorry, we are going to have root of 3. Since the denominators are equal, we add the numerators. 16 plus 12 gives us 28. So we are having 28 all over 5. Then we have 3 raised to the power of 16 all over 5, all in root. Is it equals to 27? Let's see, we are almost there. Then in this case, we want to remove this root again. To remove this root, here we have root a, which is always give us a raised to the power of half. So we have to remove this root. To remove that root, we have root of 3 raised to the power of 16 over 5 times 3 raised to the power of 28 over 5, all raised to the power of 1 over 2, equal to 27. If we continue, we multiply the powers here. We are having root of 3 raised to the power of 16 over 5 times 3 raised to the power of 2 into 28 is 14 all over 5, equals to 27. Now if we apply product law of indices, where we have a raised to the power of m times a raised to the power of n is equals to a raised to the power of m plus n, that is when we keep the base and add up the powers. And when we add up the powers, since it's identity fraction, we keep the denominator and add up the numerator. This will give us 3 raised to the power of 16 plus 14 gives us 30 all over 5. Will it give us 27? Let's see. 30 over 5 can be reduced to 5 here 1. 5 here will give us 6. Then we are having root of 3 raised to the power of 6 equals to 27. Is it true? Let's see. We can express this root to be in form of power, where we have root of a equals to a raised to the power of half. And when we apply that, we are going to have 3 raised to the power of 6 or raised to the power of half. Is it equals to 27? We are almost there. Then now we can multiply the powers. We are having 3 raised to the power of 6 all over 2 equals to 27. Is that true? Now if we reduce the power, we are having 3 raised to the power of 2 here 1, 2 here 3, 3 raised to the power of 3. Is it equals to 27? Let's see. 3 raised to the power of 3 is the same thing as 3 times 3 times 3. 3 times 3 gives us 9. 9 times 3, which is 27. 27 equal to 27. Finally, we have arrived at the answer. The answer is correct, super correct, which is 27 is equals to 27, meaning the left hand side is equals to the right hand side. So our answer is correct. Thank you for staying for too long to get to the end point of this question. If you know this help, please subscribe, like, and share. Thank you very, very much. See you in my next video. Thank you.